Hello, everybody. Today, our lesson is Add Fractions Using Models. We're on lesson 7.3, page 287 of your math textbook. And our essential question that we should be able to answer at the end of today's lesson is, how can you add fractions with like denominators using models? All right. So, unlock the problem. Ms. Clark made a loaf of bread. She used 1/8 of the bread for a snack and 5/8 of the bread for lunch. How much did she use for a snack and lunch? So she used 1/8 for a snack and 5/8 for lunch. So one way we can solve this problem is to use a picture. 1/8 is blank eighth size piece of bread. Is how many eighth size pieces of bread? It's one, isn't it? So is 1/8 size piece of bread. 5/8 is 5/8 size pieces of bread. So shade 1/8 size piece. All right, so that would be the snack, 1/8, plus the 5/8. One eighth plus 5/8. So how many parts did we shade? 1, 2, 3, 4, 5, 6 eighth size pieces, which is the same as saying 6/8. Now, you might say, well, is that in simplest form? We should say no, because we know the factors of 6 are 1, 2, 3, and 6. And the factors of 8 are 1 and 8, 2 and 4. So we see that 2 is in common to both of them, which should have been obvious because they're even numbers, and even numbers are divisible by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4. So we could say 6/8 or 3/4 of the bread will we use for lunch and snack. All right. Another way is we can use fraction strips. We talked about these yesterday. And so the strip represents a whole loaf, right? This would be the whole loaf. Each of the small pieces, or each 1/8 part, represents 1/8 size piece of the bread. So if we were using fraction strips, we would shade in 1/8 and then shade 5/8. Okay, and then we would have 1/8 here plus the 5/8, and that would give us a total of 6 total pieces shaded, which again would be 6/8 or 3/4 of the bread. All right. So explain how the numerator of the sum is related to the fraction strip model. Okay. The numerator is 6, right? So basically, the numerator is the total number of eighth size pieces. 1 plus 5 is 6, right? Because we had 1 here and we added 5 more. So that gave us 6 1/8 pieces. Explain how the denominator of the sum is related to the fraction strip model. In one whole, there are 8 eighth size equal pieces. Jacob needs 2 strips of wood to make masts for a miniature sailboat. One mast will be 3/6 foot long. The other mast will be 2/6 foot long. He has a strip of wood that is 4/6 foot long. Is this strip of wood long enough to make both masts? Okay, so he has one mast needs to be 3/6 foot long, or half a foot, and the other one has to be 2/6 foot long. He has a strip of wood that is 4/6 foot long. Is this strip of wood long enough to make both masts? So let's shade the model to see. So we have the first one, which was 3/6. And then we have to add 2/6 for the other one. And so 3/6 plus 2/6 equal 5/6. Well, is 5/6 less than or greater than 4/6? Well, it's greater than, right? So the strip of wood is not long enough. He needs at least 5/6, and he only has 4/6, so it's not long enough. How would you use the number line to determine if the sum was less than 4/6? Well, okay, so we could looking at the number line, we could just tell by looking at the number of shaded areas if the sum was greater than or less than 1/6, right? Remember, on a number line, the more you go to the left, the smaller the value on a number line. So we're going to start at 0, and we go to the right, we have 1. So the closer I get to that 0, the smaller the value. So when I look at this number line, I see that 5/6 is to the right of 4/6. So just comparing that, there's no way 5/6 can be less than 4/6 because it's to the right. Okay. 4. What if each mast was 6 foot long? Could Jacob use this strip of wood to make both masts? Well, in that case, 2/6 plus 2/6. Okay. So let's use a different color this time. And we'd have 2/6. I'm going to write it up here on top. 2/6 plus another 2/6. And that would put us at 4/6. So yes, it would be enough. Yes. Because 2/6 plus 2/6 equals 4/6. All right, number 1. Adrian's cat ate 3/5 of a bag of cat treats in September and 1/5 of a bag of cat treats in October. What part of the bag of cat treats did Adrian's cat eat in both months? So use the model to find the sum of 3/5 and 1/5. So we see 3/5 here. I want to go ahead and stay in the habit of circling the key terms and underlining the question. Okay, so we know we have to use 3/5 and 1/5, and it wants to know what part of the bag of treats did the cat eat in both months. So, all right. So 3/5, represented by the first three fifth size tiles, plus 1/5. So how many do we have there? We have 4 fifth size pieces. 1, 2, 3, 4. So 3 plus 1/5 is 4/5. 3/5 plus 1/5 is 4/5. Number 2, use the model to find the sum. So here they're saying we have 1/4 plus another 2/4. So we have a total of 1, 2, 3 1/4 size pieces, or 3/4. Number 3, 6/10. Okay, so this section here is 6/10, and we're going to add 3 more 1/10, 3/10 more. So 6 and 3 is 9/10. All right. Find the sum. Use models to help. 3/6 plus 3/6. Okay, so 1, 2, 3, 2, 4, 5, 1 more. Okay, so we have 1/6, 1/6, 1/6. So that part represents 3/6, and then we have another 1/6, 1/6, 1/6. And so that part equals 3/6. So 3/6 plus 3/6 is 6/6, or 1/2. All right, 5/8 and 2/8. Okay, so we have 8 pieces in the whole. So each of them is 1/8 piece. Okay, so they're each an 1/8 size piece. In the first part, we have 5 of them. So we have 5/8 plus 2/8. So that would be 7/8. We have 7/8 size pieces for a total of 7/8. 1/3 plus 1/3. One-third, 1/3, 1/3. 1/3 plus 1/3 is 2/3. All right. Find the sum. Use models to help. 5/8 plus 2/8. Well, you know what? We already did that model. We just did it right there. So I'm going to use the same one. It's not going to change. How many 1/8 size pieces do we have when we add 5 and 2? We get 7/8 size pieces. 7/8. 2/5 plus 2/5. All right. 2/5. Each of these pieces we're going to say is 1/5. 2/5 plus 2/5 is 4/5. Okay, 4 out of the 5 pieces are shaded. Number 9. So 6th size pieces. write in 1/6 to show what each of the pieces represent. Okay, and it's obvious that there's sixths because there's 6 sections in my whole. All right, so we're going to add 4 of them together. That would be 4 1/6 plus another 1/6. So we have a total of 5/6. 1/10 plus 4/10. So each piece in this will be 1/10. Okay, and we're going to have 1/10 plus 4/10. 1, 2, 3, 4. So we have a total of 1, 2, 3, 4, 5 tenth size pieces for a total of 5/10. 1/4, 1/4. 1/4, 1/4, 1/4, 1/4. 1/4 plus 1/4, 2/4, or 1/2. 5/10 is also equal to 1/2. Number 12. 5/12 plus 5/12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, each of the pieces is 1/12. Okay, and first section is 5 of the 12. 1, 2, 3, 4, 5. That's 5/12. And then we're going to add 5 more 12s to it. 2, 3, 4, 5. So how many total 12 size pieces do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5 and 5 is 10. So 10 12ths. If we wanted to simplify that, we would list the multiples of 10 and 12. Not the multiples, the factors of 10 and 12. 1, 10, 2, and 5. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. So we would divide them both by 2's. 10 divided by 2 is 5. 12 divided by 2 is 6. So 10 12ths or 5/6. 13. A sum has 5 addends. Each addend is a unit fraction. The sum is 1. What are the addends? Well, okay, so 1 something plus 1 something, so on. And it says 5 addends. So that's 1, 2, 3, 4, 5. And the sum is 1. Well, the only way to get a sum of 1 when we're adding fractions is for the numerator and the denominator to be the same. Okay, well, if it's a unit fraction, that means the numerator has to be 1. I have 5 addends, so the numerator is 5. And so if this fraction is equal to 1, the denominator has to be 5. So 1/5 plus 1/5 plus 1/5 plus 1/5 is 5/5, or 1. In a survey, 4/12 of the students chose Friday and 5/12 chose Saturday as their favorite day of the week. What fraction shows the students who chose Friday or Saturday as their favorite day Shade the model to show your answer. So we have 4/12 of the students chose Friday, 5/12 chose Saturday. What fraction shows the students who chose Friday or Saturday? So that means we're going to add them together, Friday or Saturday. So 4/12 plus 5/12. 1, 2, 3, 4, 5. And 4/12 plus 5/12. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 sections shaded. So I have 9 1/12 pieces. I'm sorry, 9 1/12 pieces, or 9/12. Factors of 9 are 1, 9, and 3. The factors of 12 we already listed: 1, 2, 3, 4, 6, and 12. So the greatest common factor into both 9 and 12 is 3. So I can reduce 9/12 by dividing each of them by 3, and I get 3/12. So I could say 9/12 or 3/4 of the students chose Friday or Saturday. Okay. Now, these didn't say this, that I had to simplify, but we might as well just get in the habit of doing it whenever we can. So 9/12 is what the model is showing us, but that is equivalent to 3/4. All right. 15 on page 290. Jen is putting colored sand in a jar. She filled 2/10 of the jar with blue sand, 4/10 of the jar with pink sand. Describe one way to model the part of the jar filled with sand. Okay. Well, we could call that 2/10. We could call this 4/10. So how many total pieces would that be? 4/10 plus 2/10 will give us a total of 6/10. Okay. So describe one way to model the part of the jar filled with sand. So how could we do this? Well, so we could draw a rectangle. Let's draw a rectangle for the model just to represent the fraction strips, right? So if we drew a rectangle and split it into 10 pieces, so now the rectangle represents the jar. Okay. So we have 10th size pieces. I would have 2/10 that would represent the blue, and then I would add 4 more, or shade 4 more, to represent the red or pink, and that would give us 6/10 shaded. Oh, and then 6/10, we could reduce that because they're both even numbers. 1 and 6, 2 and 3. 10, 1 and 10, 2 and 5. 2 is in common to both. So 6/10 divided by 2 is 3/5. So 6/10 or 3/5. Have you ever seen a stained glass window in a building or home? Artists have been designing stained glass windows for hundreds of years. Help design the stained glass sail on the boat below. Okay, so you will need colored pencils. For this activity, I'm just going to go ahead and write in the words that would be in each of the triangles. You can color them in. So we're going to look at the 8 triangles. Use the guide below to color the triangles. 2/8 of the triangles blue. So first off, let's see. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 triangles. And it wants us to color 2/8 blue. I don't know. Well, you decide. Where do you think the blue should go? Maybe I'm going to go blue and blue there. That would be 2, right? All right. 3/8 red. Maybe I'm going to alternate red, red, red. Orange. Maybe I'm going to go orange and orange at the corners. And then yellow. I guess maybe the yellow will go right there in the middle. Okay. So all that was telling us was out of the 8 size pieces, one of them has to be yellow. Out of the 8 size pieces, 2 of them have to be orange. Out of the 8 size pieces, 3 of them need to be red. And 2 of the 8 size pieces need to be blue. Okay, so write an equation that shows the fraction of triangles that are red or blue. Red or blue. That means add them together. Red was 3/8 and blue is 2/8. So if we're going to use a model, we're going to break it into 8 size pieces. Okay. All right, so those are our 8s. 3 of them were red. And 2/8 of them were blue. So 1, 2, 3, 4, 5/8. Oh, we have to write an equation. 3/8 plus 2/8 equals 5/8. Okay, 5's prime and 5's not a factor of 8, so that's as simple as they can get. It's simplified, I mean, it's in simplest form. Number 17, what color is the greatest part of the sail? Write a fraction for that color. How do you know that fraction is greater than the other fractions? Well, okay, so we have 2/8, 3/8, 2/8, 1/8. Well, they're all eighths, so all I have to do is compare the number of the 8 size pieces. That one has the most pieces. So the 3/8 is red. What color is the greatest? Red is the greatest part of the sail. Three-eighths is red. How do we know that that's the greatest? Red is the greatest part of the cell, 3/8. The denominators are all 8. Okay, we looked at it. They were all eighths. So all I have to do is compare the numerators. The numerators are 1, 2, and 3. 3 is the largest of those numbers. If 3 is the largest, then so 3/8 is the greatest. Simple as that. All right, so that is it for our lesson today on adding fractions using models. Tomorrow we're going to work on subtracting fractions using a model. So until then, may the numbers always be in your favor.